Hello class, welcome to our lesson today dealing with section 5.1. This changes a little bit of pace. There's some topics that are kind of review to what we've done before and then some new ideas. This deals with what are known as the identities of trigonometry, and so we'll look at what some of those are and how to use them and how to apply them in certain situations. The first set of questions that you'll see on your homework and in a test situation are similar to ones that we've done before. It's just it's been a while since we've looked at them. So these questions will give you some ratio, like this says cosine is 4/5, and it'll tell you that the angle's in quadrant 4. So if you remember, our strategy was this is x, y, and r, and they have to be in quadrant 4, so the y value has to be negative. You'll use the Pythagorean theorem to find the answer to each of these scenarios. So for this case, the y value is going to be -3, and then sine of theta would be -3/5. Some questions may ask you to find all of the other trig functions. Some may just find one of them. I figured if you can get it set up, you can find the rest of them yourself. The second one says cotangent is 1/3. You could use SOHCAHTOA to set that up, x, y, and r to set that up. You could also say that tangent is 3/1 then. Notice that it's in quadrant 3. That means that the x and y values were both negative. Okay, so the adjacent is -1, the opposite is -3, and that would end up being root 10 for the r value, or the hypotenuse. Remember that r value, the hypotenuse, is always positive because it's the distance from the origin. And then when you get an answer on this question, don't forget you have to rationalize the denominator. Anytime you're looking at these scenarios, make sure you rationalize the denominator. That's probably what they're looking at, in these situations. The next one should be really easy if they give you cosecant. Remember, cosecant is just sine's reciprocal, so it should just be flipping it around. That's why it doesn't have any other extra info. The one on the right here, you have tangent -√7/2. Remember, one of these pieces is negative. That will be determined on which quadrant it's in. And there may be some questions where they set it up where they just tell you something's greater than 0. So this says secant is greater than 0, which means cosine is also greater than 0. That puts you in the fourth quadrant, which makes the y value negative. Don't forget you have to rationalize the denominator. As you're looking at this answer, the sine value should be negative. Okay, the next thing that we need to discuss are the trig identities. There is a handout that I've posted and that you want to look at. I would say that eventually all the pieces are fair game. You want to focus in on the first 3 or 4 sections dealing with reciprocal identities, which are, sine of x is the same as 1/cosecant, for example. But the ones that you want to pay close attention to are what are known as the Pythagorean identities. They start with sine squared plus cosine squared equals 1. And then there's manipulations of that by dividing that deal with cotangent and tangent, secant and cosecant. Those are probably the new ones that you want to focus on as you're looking at these questions. The problem with trig identities is that it takes a lot of work in order to figure out kind of what strategy to use on each question. Since I've been looking at this a long time, or someone that's looked at trigonometry a long time, I already kind of can tell what the first step's going to be in a question. So my goal is to give you some suggestions about what you should be looking at. And the first suggestion is always going to make everything sines and cosines, and hopefully things cancel out. That's going to be true if there's a lot of multiplying involved. So my suggestion is always, if you don't know what to do, if you're completely stuck, make everything sines and cosines, and that might help you get the answer for these scenarios. So if you look at these 3 questions, notice all of them deal with multiplication of trig functions. So tangent, by definition, is sine over cosine. That's in your quotient identities. You want to make sure you look at that. And then times cosine, you notice these cosines cancel and you're left with sine of theta. Don't forget the variable in all of these answers. Sine theta times secant theta, you say, I don't know what to do. Make secant into 1/cosine, multiply it together. That's sine over cosine, which is tangent of theta. And on this last one, you make everything sines and cosines, and everything will start canceling, and you'll be left with 1. So the first suggestion is the main suggestion, which is if you get stuck, make everything sines and cosines, and maybe it will cancel out. The next piece is if it looks like it needs to be distributed, it probably can be. The trouble is with this question is the fact that you may notice if you see 1 plus something squared that that's probably a Pythagorean identity. Same with 1 minus. You can manipulate those around in order for them to be the same. But when you're dealing with these questions, you want to make sure that you're looking at it from the perspective of those identities. So if you look on your paper, 1 plus tangent squared is the same as secant squared, so I just change it to secant squared. Now notice here, they are squared, but they're still just two things multiplied to one another. So change things into sines and cosines. Cotangent is cosine divided by sine, and you just square both of them because it's cotangent squared. Secant squared is 1 over cosine squared because it was 1 over cosine is the same as secant. The cosines cancel. You get 1 over sine squared, and that's the same as cosecant squared. The question normally comes up, well, how do I know if I have the right answer or not? Typically, you want less division in your answer, so like 1 over sine squared is a pretty good answer considering what you started with. But if you can get rid of the division, it's going to be helpful as you're looking at that situation. The next suggestion is if it looks like it needs to be FOILed and distributed, it probably needs to be. Okay, so I'm going to do first outside, inside, last. Secant times secant is secant squared. Secant times plus 1 is plus secant. Secant times minus 1 is minus secant. And then plus 1 times minus 1 is minus 1. This is difference of squares. So the middle terms will go away. And that's going to be the case in a lot of trig function identity questions, is that the middle terms probably are going to go away as you're going through the situation. Next thing to note is that you get secant squared minus 1. If you look on your trig identity piece, it says that tangent squared plus 1 is secant squared. If you just move the plus 1 to the other side, that will make it tangent squared equals secant squared minus 1, and that's why your answer can end up being tangent squared of theta. The next question is one that trips up a lot of people, but it's actually a really easy question. If you see a lot of things with adding and subtracting divided by one thing, you just need to split it up and make multiple fractions. So 1 plus cotangent over cotangent of theta, you just make it 1 over cotangent theta plus cotangent theta over itself. 1 over cotangent, if you look at your reciprocal identities, 1 over cotangent is the same as tangent on the top. And then cotangent over cotangent is 1. That's as far as you can really go. If it was cotangent squared, you could change it to something else with your Pythagorean identities. But since it's just since it's just tangent plus 1, you have to leave it as written. You'll notice there will be some questions that have a negative sign. There's some odd and even function identities on your paper. A lot of those odd and even identities will end up being squared. And what will happen is that negative really won't affect it if it's odd or even, because when you square it, it's going to go away. And so if you see something square with an identity or a negative angle like this, you can basically ignore it at that point. If it's not squared, you have to pay attention to it. 1 minus sine squared is cosine squared. If you're not sure how that works, sine squared plus cosine squared equals 1. And so you move it over to see what you get. Move the sine squared over to the other side. So cosine squared equals 1 minus sine squared. Cotangent squared plus 1 is the same as cosecant squared. This answer here is pretty good, but remember, if you can get rid of division, you want to do that, and so you just make it sine squared times cosine squared. But realize this does not equal 1 because it's not plus in the middle. Since it's just sine squared times cosine squared, you have to leave it as written. Okay, that gives you an intro to section 5.1. The first group of problems I think will be a lot easier with the X, Y, and R ideas. The second group of problems, you want to make sure you have that PDF of all of the identities written out or printed out so that you can use that in order to be successful on those questions. Have a good day, everyone.